South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.
Good morning, good morning, good morning. It is the Grade 10 Awqaf SA Pure Maths Workshop coming to you live from Ekailicha in Luhlaza High School. We've got different schools on the ground. Manyano is here, Zola Business School is here, Masile is here, Bulumko is here, and all other schools are on the ground. So do make sure that you come by and join us here, because I promise you the experience of the workshop is quite more different than when you are looking coming to us live here at Luhlaza. He will be doing different topics. The paper 2 of the Grade 10 Pure Maths Awqaf SA workshop is coming from Joburg, so it can be difficult for you to come around from a and be with us here today. I'm your host, Khalid Kungani Party, and as always, we will be talking to students at break time to see how they are feeling here today. We should be talking to the deputy principal of Luhlaza High School, but she is yet to arrive. So we will give it to Mr. Kota to get us going for paper 2, Pure Maths workshop. Mr. Kota, welcome. And what is it that we need today?
Good morning, good morning, good morning. How are you, learners? Give yourselves a nice round of applause. Good morning. A beautiful, crisp Sunday morning here in the Western Cape. Another great day in Cape Town, and beaming from here to the rest of the country and to the rest of the world. We got expats from all over the world that are tuning in to today's program. Guys, I hope you guys managed paper 1 yesterday. I hope you went through all the work. I hope you had time. I know it was a long day. We did a lot of work. Remember, these sessions are recorded on the Awqaf website, so you can always click on it to review, to replay, and to revise. So we've got learners coming in from a whole lot of different schools. We had close to 900 learners on site yesterday, and we had close to about 4,000 learners online. I think it's going to be much more today. So guys, I hope you guys are ready. We're in preparation for the June exam, Maths paper 2. So we've got Maths paper 2. What are we going to be doing in Maths paper 2? We're starting off the first session with analytical geometry, analytics. We're then going to go into the whole of trigonometry. That would be after break. And then we will do Euclidean. That would be our last session for today. Euclidean geometry. Total marks 100. Some of them would be 75 or 100. I think you'll be writing about a 2-hour paper, or what? No, it can't be a 1.5 hour. I think it would be a 2-hour paper. Learners who are coming in, come in quietly. Take your seats. We're about to launch for today's program. Onliners, Khalid, how's our onliners doing? Are they fresh? Are they ready for action?
The onliners are here with It's Me saying that good morning to everyone. Hasanain Abdullah is also joining us online, by the way, saying,
Assalamu
let's go.
alaikum.
We've got Elijah Swart as well from Portland High School that was hosting last week the Grade 11 Maths workshop, as well as Linando Bene from Western Cape, coming from Epandulwazi, a lower crossroad.
Okay, beautiful, beautiful. Give us your shout outs. Hit us up in the comments. Guys, we are in preparation for the June exam. So yes, I will be explaining to you every topic. We'll be doing some mock examples. We'll be doing some mock templates. And like I said, if you pay attention, if you hang on to every word we say, you shouldn't have a problem in your exam. So guys, another big warm welcome to everybody. Let's get started. Take out your books, take out your scientific calculators, take out your stationery. Let's get started with analytics. Right. Thank you. Analytical, let's start off with the diagram here. Let's start off with the diagram. This is paper 2. Analytics deals with coordinates. What do we need to know about coordinates? And here are your formula. Guys, these formulas, you remember it from now right through until grade 12. Don't forget these formulas. The first formula that we need to know is the distance formula. So let's give you a set of, let's give you a diagram. Let's draw a diagram here. There we go. Let's draw a triangle. Sometimes they might even give you a quadrilateral. They might give you, okay, in fact, let's do this. Let's do this. Let's give you quadrilaterals. Right. Let's give this some pairs of coordinates. Let's call that P2 and 20. P2 and 20. Let's call this PQ. Q, let's call that minus 10 and minus 4. Let's call this R, 6 and minus 12. And let's call this point S, X, and Y. So the first formula that we need to know, that's your y-axis, that's your x-axis. The whole of analytics will be dealing with the Cartesian plane. So the distance between, so we use the distance formula. When do we use it? For calculating the length of a line. Can you guys all see on the board clearly? Can you, do you want the pen thicker or like this? It's fine. Slightly thicker. There we go. Right. The length of a line, and let's call that PQ is equal to, please guys, you need to memorize these formulas. I remember in the week in Gauteng, there was a memo that came out that gave strict instructions, no formula sheet. You'll only get your formula sheet in, they said final exams or in matric finals. So we saw a circular in Gauteng that came out that said, please do not issue learners formula sheet. So PQ is x2 minus x1 all squared plus y2 minus y1 all squared. Please remember these formulas. First is your distance formula. To calculate the length of a line, why do we need to calculate the length of a line? For area, proof shapes. Number two, very important formula, the gradient formula. Now we say the M of PQ. You all know the gradient formula, y2 minus y1 over x2 minus x1. What is your gradient formula used for? It's used to prove parallel lines. Parallel lines. We all know that the gradient of line 1 is equal to the gradient of line 2. Yes or no? And we also know for perpendicular lines, the M of line 1 multiplied by the M of line 2 must equal to -1. Right. We also use the gradient for collinear points. What does collinear mean? Do they lie on a straight line? Say points A, B, and C, and we need to prove whether A, B, and C are collinear. Then the gradient between A and B must equal to the gradient between B and C. If the gradients are the same, they lie on a straight line. So the first formula that we have is the distance formula. The second formula that we have is the gradient formula. Yes.
The register will be going around. Do not write your name if you are here yesterday. What you can do is tick next to your name on under Sunday. Thank you very much. So if you can't see your name, there are different registers from the same school. I will make sure that it comes through.
Thank you. Right, let's go. The next formula that we need to know is the midpoint formula. So the midpoint of a line, this is M the midpoint, not M the gradient, M the midpoint, we all know is x1 plus x2 over 2, y1 plus y2 all over 2. And then we have the equation of a straight line. The equation of a line. And we all know that the equation of a line is y equals mx plus c. Yes or no? Now, I just want to give you one more formula for equation of a line. If any point, if any one point and the gradient is given, then we can use y minus y1 equals m into x minus x1. I'll show you how to use that formula to get y is equal to mx plus c. Now, this formula you'll be using in grade 11 and 12 a lot. I don't think generally they introduce it to you at grade 10. But if you did use it, it shouldn't be a problem. You can use that from now right through until grade 12. So here's your formulas. Here's your formulas. Memorize it. Memorize these formulas because we are now going to be applying it, guys. Midpoint formula, equation of a straight line, grade 10s. What an amazing sight to see 500-600 learners already here, maybe more, that have converged for a single mission to master mathematics on a crisp Sunday morning where they could have been sleeping, they could have been camping, they could have been studying, they could have been doing any other thing, but they decided to come to a single venue. There's more learners still coming in. You guys are absolutely amazing, and this shows your dedication, it shows your commitment, it shows your hunger to succeed. So well done to all of you. Okay, so let's get started. We're going to push from now. Our first break, it's 9:15. We will push through until 10:30. We will push through until 10:30. Let's go. I'm going to use the same diagram. Let's give you a host of questions on this diagram, and then I'm going to give you one to do after this to see how much you can score for your exam. So let's go. Let's start with this. Let's do it question for question. Question number 1, they want the gradient of PQ. They want the gradient of PQ. A question like this, 3 marks or 2 marks. Now guys, analytics is very easy. Do not throw away these marks. This is going to help you to score. Right. So we're going to say, to answer question number 1, we're going to say the M of PQ is equal to, please start with the formula, y2 minus y1 over x2 minus x1. So the M of PQ, let's call this, you can call any, so let's call this x2, y2. Let's call that x1, y1. So y2 minus y1, minus 4, plus 4, over x2 minus x1, minus 10, plus 10. Twenty plus 4 is 24, over 2 plus 10 is 12. 24 over 12 is 2. So the M of this line, not M the midpoint, M the gradient, is equal to 2. This is M the midpoint. So now we have the gradient of the line. Question number 2. They want the equation of PQ for 4 marks. Take this down. Guys, you're going to need this for grade 10, 11, and 12. So make sure you master it today. Master it here with us as we are doing it. Item for item, question for question. Onliners, how are we doing? Everybody all good? Onliners are actually sitting at home with a nice cup of coffee and donuts. Good sisters in the morning. I know Gauteng is freezing, KZN is freezing, Cape Town is crisp. Right, so we got this one. The equation of PQ. Let's do number 2. Now remember, remember that last formula I gave you. You took down those formulas, right? What did I say? When the gradient and any point is given, so the gradient, the m is equal to 2, and then we can use any coordinates on PQ. I'm just going to use P2 and 20, right? Now watch. So I'm going to call this x1, y1. So let's go with that new formula I showed you. Y minus y1 equals m into x minus x1. Right, now watch. I know many of you have, but see how nice it is. Throw substitute in here, you plug and play, you'll get y is equal to mx plus c. So let's go. Y minus y1 minus 20 is equal to m, which is 2, into x minus x1 minus 2. Now all we do, we remove the brackets. Y minus 20 is equal to 2x minus 4. Here's your final answer coming up. Y equals 2x minus 4. Minus 20 will come on that side as plus 20. Here's your final answer. Y equals 2x plus 16. So you don't have to use y equal mx plus c, then put in the coordinates, then find c, then take c, then put it back in. It's a lot of work. So here's one formula that you can use right through until grade 12 when the gradient and a coordinate is given. Right? Have we all got this? Right. Question number 3. We want an equation of a line 90 degrees perpendicular to PQ. From point R for 5 marks. We want an equation of a line 90 degrees to PQ from R. So you all got the number 2 down? Right, so what does this mean? What does question number 3 mean, guys? From point R, we want a line perpendicular. Now we don't know exactly where it is, so I'm not going to put it on my y-axis. So I'm just going to say perpendicular to PQ. There we go. Equation of a line 90 degrees or perpendicular to PQ from point R. So from R, we draw a 90-degree line. Now we want the equation of this line. What do we need for an equation, guys? We need a gradient and a point. Am I right? What do we need? Gradient and a? Good. So now let's do this. So what will the gradient of this line be? The m of this line, because it's perpendicular, the m of your new line is going to equal to, if this one is positive, this one will be negative. If this one is 2 over 1, this one will be 1 over 2. We change the sign and flip the fraction. Why? Old gradient times new gradient must equal to how much? Negative 1. Yes or no? Right. Okay. And we got a point. We got point R. I want you to do it exactly like we did the previous one now. You got the gradient, you got a point, use that formula that I gave you, y minus y1, use y minus y1 equals m into x minus x1. Use this formula and get me y is equal to mx plus c. Use this formula and get me y equals mx plus c. Come guys, it shouldn't take you long. It should take you probably 30 seconds at maximum. Right, so y minus minus 12 plus 12 is equal to m, which is minus a half, into x minus 6. Now remove the brackets. Y plus 12 is equal to minus a half x. Negative times negative is a positive. 1 times 6 is 6 over 2 is 3. Here's your final answer coming up. Y equals minus a half x plus 3 minus 12. Y equals minus a half x plus 3 minus 12 is how much? Negative 9. And there we go, we are done. And you got yourself 5 marks. So at the moment we're sitting with 12 marks for this question already. Agreed? Thumbs up? Are you understanding? Good. Next question. Find the midpoint of PQ. The next question, they want the midpoint of PQ for 3 marks. So we are already on 15 marks after this. It will probably be about 20 marks. Find the midpoint of PQ. Right, so which formula do I use? Obviously, what formula do I use? Midpoint. Right, so the midpoint of PQ, is going to be x1 plus x2 over 2, y1 plus y2 over 2. So this is equal to, right, the midpoint of PQ, so we're going to use this, x1 plus x2 minus 10 plus 2 over 2, y1 plus y2 over 2. That will give me minus 8 over 2 is minus 4. 16 over 2 is 8. So the midpoint here is negative 4 and 8. Light work, easy stuff. So we're on 15 marks again. Already 15 out of 20 marks. Maybe 25 marks. Okay. Now let's see how smart are you. I want the area of triangle MQR if M is the midpoint of PQ and MR. Wait, all right. So let me write the question down for you. Right. The next, what number is this? What question number is this? 5. Right. Find or calculate the area of triangle RMQ, RMQ, RMQ if MR is perpendicular to PQ for 5 marks. So now they're telling you the triangle. So let's draw this triangle. RMQ, RMQ. And they're telling you that MR is perpendicular. How do we calculate area, guys? Area of a triangle, of a 90-degree triangle is what? Half base. We know area is equal to half base times perpendicular height. Yes or no? So calculate your base. Calculate the length of your base. Calculate your length there. That's your base. Or this is your base. Half base times perpendicular height. Go for it. Calculate what is the length of MQ or QM. QM is equal to the square root of x2 minus x1 Yes or no? So what is QM equal to? The square root of x2 minus x1 all squared minus 10 becomes plus 10 plus y2 minus y1 minus 4 plus 4 all squared. QM is equal to the square root. This is 6 squared is 36 plus 12 squared is 144, which is equal to the square root of 180, which is equal to, go to your calculators, the square root of 180, 6 root 5. 6 square root 5. Don't use decimals. 6 square root 5. That's the length, units. So you say units. Right, now we need to find the length of MR. So MR is also equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So MR is equal to MR x2 minus x1 all squared plus y2 minus y1 all squared. This is equal to the square root. 10 squared is 100 plus minus 20 squared is 400. which is equal to the square root of 500, which is equal to the square root of 500, 10 root 5. 10 square root 5. So this is 10 square root 5 units. So those were the two lengths of the two lines. The length, the distance of QM, the distance of MR. We now need to find the area. Yes or no, guys? So let's all do the area. What is area equal to? Area is equal to half base times perpendicular height, which is half 6 root 5 multiplied by 10 root 5. This is equal to root 5 times root 5 is 5. So 6 times 10 is 60. 60 times 5 is how much? 300. 300 divided by 2 is how much? 150 units square. There we go, another 5 marks. So we're already on 20 marks. We are already on 20 marks for analytics. Right, I know many of you have taken this one down. The next question, you can start. I want the coordinates of S, X and Y, if PQRS is a parallelogram, is a palm. They're telling you PQRS is a parallelogram. You need to find the coordinates of S for 5 marks. Take this one down, try it. I'm just looking for another question here that I'm going to give you guys to do on your own. Take that question down. Okay, here we go, guys. You've taken this one down. Can I erase the previous one? Lovely. Let's end up this question. The coordinates of S, X, and Y if PQRS is a parallelogram. Guys, this is a topic you can score full marks in. Full marks. It's just application of formula. Right. Now, I'm going to give you a clue, or I'm going to tell you what to do. Whenever they tell you this is a parallelogram, you always, to find X and Y, another pair of coordinates, don't use gradient. Don't use distance. Use midpoint formula. Why? Because the diagonals bisect each other. Watch here. We got a diagonal here. We got another diagonal here. And they meet at a common point, a common midpoint. Because in a parallelogram, what do we know? That the diagonals bisect each other. Yes or no? Right, so it's the same midpoint. It's the same midpoint. Right. So let's go. Let's go. Right. So now let's find the midpoint of PR. Do you want to do it on your own? You want to try it on your own? Go for it. Go for it. It's worth 5 marks. I'll give you 2 minutes. Come guys, you got 2 minutes. 2 minutes, work it out. Right, so let's find the midpoint here. The midpoint of PR is x1 plus x2 over 2, y1 plus y2 over 2. So 2 plus 6 over 2, 20 minus 12 over 2, 8 over 2 is 4. There we go, that's 4. 20 minus 12, 8 over 2 is 4. So it's 4 and 4. Right, now how do we find S, the end point of this line? Because this is also the midpoint of this line here, QS. How do we do that? Come guys, not difficult. Not difficult at all. Are you still taking the previous one down? Come, hurry up, hurry up, hurry up. Right. After this, all of you, I'm giving you an example. I'm going to give you guys about 10 or 15 minutes to do that entire exam model. And let's see how much you score. This is going to test how ready you are. How many of you are writing tomorrow paper 2? Whoa, good luck, good luck, good luck. That's why you're so early here today. Right. Pay attention. Now to get S, X, and Y, this is what we're going to do. Pay attention here. So all we do, we say X midpoint is equal to X1 plus X2 over 2. We're making an equation. And we say Y midpoint is equal to Y1 plus Y2 over 2. This is if the midpoint is given. If the midpoint is given, then you can use this formula, or you must use this formula. There's no other way of you finding it. Using midpoint. So let's go. X midpoint is 4, is equal to X1, which is X, plus X2, which is minus 10, over 2. Y midpoint is equal to Y plus Y2, Y1 plus Y2 over 2. Now solve for X and solve for Y. So multiply by 2. Multiply this side by 2. By 2, 2 and 2 will cancel. 4 times 2, 8. equals x minus 10. X will equal to 8 plus 10 is 18. Times this side by 2 times that by 2. 2 and 2 will cancel. 8 equals y minus 4. Y equals 8 plus 4 is 12. And there we go. That is S's coordinates, 18 and 12. Done. S's coordinates is 18 and 12. That makes PQRS a parallelogram. They're telling you it's a parallelogram. They're telling you it's a parallelogram and you needed to find a... Please, I know many learners, you want to go and use the gradient formula, you can. You're going to find the gradient of the first line, gradient of the second line, equate them, and you'll get equation number 1. Then you're going to find gradient of the one line, gradient of the other line, equate them, you're going to get equation number 2. Then you're going to have to use simultaneous equations. That's a lot of work. You want to stay away from that. You want to avoid that scenario. It's not wrong. It's just very long. And there's a big chance you might make a mistake. So just stick to the midpoint formula, the 2 midpoints. You'll always be a winner. Okay, we sharp. All the learners in red, so bright here. That must be Mañano, right? I know Mañano is not far. It's just around the corner here, isn't it? I did big workshops in Kailicha. I spent over a month in Kailicha in 2012. Dr. Harry Gwala, Kwamfundo. Is Kwamfundo here? Where are you? Hello, you're right there in the corner. What time you came? 9:45. No, I'm joking. No learners from COSAT here. Pandulwazi? No? All right. Okay, good. Right, are you ready to do one on your own as practice for your exam? All right, let's go. Take this one down. Let's see. Let's see. Quite a bit of marks on it. So let's take this one down, guys. Let's take this one down. Okay, let's give it to you. Let's draw it in red. -7 and 4. Okay, so that's a straight line. Yeah. Take this diagram down. This is from a... Take it down, take it down, take it down. That's your diagram. Let's give you the coordinates and the questions. This is an exam model. P -7 and 4. That point is P -7 and 4. This point is Q, minus 2 and 4. This point is minus 7, minus 1. That's S, negative 7, negative 1. That's O. R2 and negative 5. This point here is R2 and negative 5. Yeah, that's it. Question number 1. Let's go. Prove that SQ perpendicular to PR. Prove that SQ is perpendicular to PR. I'll give you your mark allocations just now. Prove that PQRS is a kite. Number 3, if RSPZ is a parallelogram. Okay, here we go. If RSPZ, there's no Z there. RSPZ is a parallelogram. So I'm just trying to think, if you had it something like this, like that, I would say then this point would be somewhere there. So this S P Z must come down this way here. Yeah, if RSPZ, that's a Z, guys. I just put a line so you don't confuse it with the 2, is a parallelogram. Find the coordinates of Z. Number 4, the area of triangle PQRS, the area of triangle PQRS. Right. I want an equation of a line parallel to PS, passing through R. And let's give you one more question. Let's see. Right. I want an equation of a line. Equation of a... The equation of the perpendicular bisector of QR from S. Right, here we go. Let's give you mark allocation. Prove that this is that for 4 marks. Prove that that is a kite for 4 marks. Prove that this here, another 5 marks. The area, 5 marks. The equation of a line, 2 marks. Perpendicular bisector, 5 marks. 4 and 4, 8 and 5 is 13, and 5 is 18, 20. You on the dot. Here's a small test for you. I will give you until 10. It is, but 25 marks divide by 2, 12 and a half minutes. Basically, I'll give you till, it's 9:53 now. I'll give you till 10 past 10. Till 10:10. You got 15 minutes. 15 minutes. Let's see how much you score. Here's a quick 15-minute test. And at 10 past 10, we mark. And that will take us to our first break. So I'm giving you 15 minutes, guys. We're going to go for break. We come back. And we're going to crack the whole of trigonometry. Onliners, are we all right? Are you guys winning? Learn this model. This is from a past paper. This is from a past paper. So you got 15 minutes, guys. 15 minutes. I'm going to take a quick bathroom break. When I come back, we mark. Test yourself. Test yourself. Let's see how much can you score. How ready are you for tomorrow's exam?
Akomntu ukwazi ucula igwitsha sihlabeleni. Niyacula nje ku-TikTok, sikhona isikole esiculayo apha ku-TikTok ndiyasazi. Uphi? Okay. Yes. Yes. Nifune iphi ingoma yabuza nifune iphi ingoma? Unamathemba. Ake uthakayazi uba macule phi animxelele uba macule phi. Ukhona mnye ne-confidence. Hey, what's up, chat? Hey, it's your boy DK12. Eyo. 1 2 1 2. Ukhona umuntu ofuna usiculela. Nathi ofuna usithulisa. Nangiya umfundo.
Iye mama, iye mama, niketewe na iye enguwewe ta, enguwewe ta. Obamulame iye mama, iye mama, nike tewe na iye nguwewe ta, nguwewe ta. Obamulame iye mama, iye mama, nike tewe na enguwewe ta, enguwewe ta. Iye mami ewe alala iye, iye alala iye alala iye ma siti welele, siti welele. Iye mami, iye mama. Iye mama evulela mandwe, ivulela mandwe na amandwe. Iye mama vulela mandwe, ivulela mandwe na amandwe. Iye mami evulela mandwe, ivulela mandwe na amandwe. Thank you.
Okay, we're back. 10:10. Let's do. I guess you weren't working, you were singing. Okay, here we go. Let's mark. And this will take us. I bought you coffee. I went to the garage. And I bought for you your pie and I bought for you. These guys won't buy you nothing. Right, let's go. Let's go, right. Take your seats. Let's mark. Let us mark. Yeah. Okay. Prove that SQ. Right, we're going to move a little fast here. Take your seats, grade 10s. This is going to take us right through. We're going to mark this. And this will take us right through until break. This will take us right through until break. Right. Thank you, grade 10s. Right, there we go. Prove that SQ. SQ is perpendicular. Whoa, SQ. Perpendicular to PR. Yes. So we need to prove that this is 90 degrees here. We need to prove it. So we're gonna do the M of SQ. M of SQ, Y2 minus Y1 over X2 minus X1. So Y2, I'm going to call this X2, Y2. I'm going to call that X1, Y1. We always use X1, Y1, X2, Y2. Thank you. Y2 minus Y1 over X2 minus X1. That will give me 5 over 5. And 5 over 5 is 1. Now let's find the M of QR. The M of QR is equal to also Y2 minus Y1 over X2 minus X1. No, PR. Oh, wait. Okay. To PR. Sorry. So it wasn't that. It's SQ to PR. That's these two. Right, so we found SQ, the M of SQ. Right, let's find the M of PR. The M of PR. SQ perpendicular to PR. There we go. This is also Y2 minus Y1 over X2 minus X1. And this is equal to 9 over minus 9, which is equal to minus 1. Now this is 1 and that is minus 1. Therefore, the M of SQ multiplied by the M of PR is equal to 1 times minus 1, which is equal to minus 1. Therefore, SQ is perpendicular to PR. There we go. Those two are 90 degrees. Right, the next one. Prove PQRS is a kite. Prove that PQRS is a kite. Bring that packet on the chair there at the back. Behind, yeah? There's a packet there on the chair. With donuts and everything. Bring it. Right. Prove that PQRS is a kite. Can I erase number 1? Who's still writing? None. Right, number 2. For it, now we know that the diagonals are bisecting each other at 90 degrees here. What we can do, we have to prove, we can prove that this side is equal to that side and prove that this side is equal to that side. Thank you. Take care for you also. Right. Therefore, it will be a kite. So let's see, what is the distance of PS? PS is equal to, now this here is a straight line. That's minus 7, that's minus 7. So from 4 to 1 to minus 1, how many units is it? From 4 to -1 is how many units? 5. Is 4 plus 1, which is equal to 5. Right. PQ. Say Y value between -7 and -2, how many units is it? 5. It's a straight line. It's a straight line. And for me, sugar in mine also. Here's my, here's it. 2. Please. Right. So now we need to find the distance of this line and the distance of this line. So SR is equal to the square root of x2, let's call this one x2, y2. So x2 minus x1 all squared plus y2 minus y1 all squared. SR is equal to the square root of -9 squared is 81 plus 4 squared is 16. So SR is the square root of 97. Now we need to find the length of QR. QR is also equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. QR is equal to minus 4 squared is 16 plus 81, which is also square root of 97. So look what has happened. We got these two. We got that as root 97. We bisect each other at 90 degrees. Therefore, what is it? What shape is it? Therefore, so now you can say PS, so you can say therefore PS equal PQ, and you can say therefore QR. Boys, it's too much talking then. QR is equal to SR, therefore PQRS is a kite. Done. So we got 4 marks and 4 marks. That's 8 marks. Guys, the next one's going to be quite easy. I showed you how to do it in the last one. If RSPZ is a parallelogram, now there's no Z. You're going to have to put Z on the diagram. Anyway, but it must look like a parallelogram. Find the coordinates of Z. So we're going to use that midpoint theorem again, like I showed you in the previous one. So we're done with the first two. Right, where is Z? RSPZ. RSP. I would say Z would be somewhere here. I would say we can draw that and draw that, and that's a parallelogram. We can call this point Z, X, and Y. Can you guys see how we're doing it, guys? They're telling you RSPZ. They didn't give you Z. So draw. So here we go. RSPZ. RP. The only other place, it can't be here. It needs to be a parallelogram. So we put the point somewhere here so that it can look like a parallelogram. There we go. RSPZ is a parallelogram. That's Z. X and Y. Why? That line will be parallel to that line, and this line here will be parallel to that line. Are you all with me? Right. Now let's find z's coordinates. What did I say? What are we going to use? Which formula are you going to use? Come on, if you listen to me in the last one, which formula do we use? Midpoint, very good. So now let's go again, midpoint. So from there to there and from here to here, we're going to find the midpoint here. Right. So we're going to say the midpoint of which line? PR. The midpoint of PR is x1 plus x2 over 2, y1 plus y2 all over 2, x1 plus x2 over 2, y1 plus y2 over 2. Am I right? Right. Minus 7 plus 2, minus 5 over 2. And that will give me minus 1 over 2. Now, although it doesn't look like minus half, this one is above, it's not drawn to scale. So this point had to actually be there. But according to our calculation, it's correct. Now, that point is minus 5 over 2 and minus a half. Again, I'm saying, you might ask, but how can this be, it's above your x-axis, how can it be negative? I didn't draw this to scale. But according to calculation, we are correct. Right. Now let's find the coordinates of z. So now to calculate z's coordinates, we're going to say x midpoint is equal to x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 over 2. So z's coordinates is x midpoint minus 5 over 2 is equal to x minus 7 over 2. Y midpoint minus a half is equal to y minus 1 over 2. Let's solve for x and y. Here's z's coordinates coming up. Multiply this side by 2, multiply that side by 2. X is equal to, if I leave this on this side and take the 7 on the other side, minus 5 plus 7 is 2. So z's coordinates is 2. And what's its y value? Times this side by 2, times that side by 2, minus 1 plus 1. Y is equal to 0. Sure, that means that point lies on here, guys. That means this point lies, we just drew a random point, but by calculation, we get y is equal to 0. Actually, the parallelogram lies on this line here. That's the point, Z2 and 0. Supposed to be there, but it's fine. We're almost there. We got 6 minutes for break. We got 6 minutes for break. The area of triangle PQRS. Where's PQRS? P, Q. Whoa, okay. Now this looks a bit rough here. Let's see how far back we can go. Let's see how far back we can go, because I need space. Damn! Now we're going to redraw the thing. All right. So I'm just going to draw a rough sketch here on the side. So we got PQ. Right, I'm just doing this here again on the side. P minus 7 and 4. S minus 7 minus 1. Q minus 2 and 4. R 2 and negative 5. And then we've got another line going this way. From there to there. And we know that all this is 90 degrees. Quiet, quiet, quiet. How are we going to find? It could be worth 5 marks. It also could be worth 6 marks. Okay, quiet. Grade 10s. PQRS. So we're going to find the area. Watch here. To find the area of PQRS, I'm going to find the area of this triangle. Then I'm going to find the area of this triangle. And I'm going to add the two areas up to give me the area of the whole quadrilateral. Listen. So the area of triangle PQS, remember I'm going to find the area of that triangle first. So the area of triangle PQS is equal to half base times perpendicular height. So that's your base. That's your base. Right. And O, did they tell us that O is the midpoint there? PQRS, PQ. Oh, it's a kite. So obviously this here, there's a lot of work here. There's a lot of, because firstly we need to find the perpendicular height here. And we know that this piece here is equal to that piece because that's a kite. There's so much of noise at the back. Right, so firstly, let's find the midpoint of SQ. Right, the midpoint of SQ. The midpoint of SQ is x1 plus x2 over 2, y1 plus y2 over 2. That will give me minus 9 over 2. This will give me 3 over 2. So here we go. The midpoint here is 9 over 2 and minus 9 over 2 and 3 over 2. Right. Now we need to find the length of SQ. SQ is equal to, because we need to find the area. So the length of this line is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So SQ equals, now you can go straight to your calculator, the square root of 25 plus 5 squared is 5, 5 squared is 25, plus 25 is 50. Square root 50 is 5 root 2. Right. So we know that SQ is 5 root 2. Now we need to find OP. OP is the perpendicular height. OP. OP is also equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So OP, the perpendicular height, square root of, do it on your calculator, open brackets, minus 9 over 2, close brackets, squared, plus, guys, open brackets, fraction, 3 over 2 minus 4 squared. Root 106 over 2. This here is square root 106 over 2. I'm going to double check it. The square root of open bracket fraction square root of x2 minus x1 all squared, x2 minus x1 all squared plus y2 is 3 over 2 minus y1 minus 4 all squared. No, I get 5 root 2 over 2. 5 root 2 over 2. So we get 5 root 2 over 2. So the area of the triangle is equal to half of 5 root 2 multiplied by 5 root 2 over 2. 5 root 2 over 2. So area is equal to, let's work this out. So 5 times 5 times 5 is 25, times 2 is 4, over 2 times 2 is 4. 4 and 4 will cancel, 25 units squared. So the area of triangle PQS is 25 units squared. Now we need to calculate the area of the bottom triangle. Okay, it's 1033. It is 1033. Do you want to finish this one and then we go for break and then we'll finish the last two after break? All right, so let's finish this one. Okay, here we go. Now we need the area of triangle QSR or QRS. This will be half base times perpendicular height. We got the base, we need the perpendicular height. So that means we need OR. OR is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. OR is equal to the square root of minus 9 over 2 squared plus open bracket fraction 3 over 2 plus 5 squared. Boom. We get 5 square root 10 over 2. So area will equal to half of 5 root 2 multiplied by 5 root 10 over 2. This is equal to multiplied by 5 root 2 and we divide that by 2. We get 25 root 5 over 2. If we convert this, I get 27,95. So the area of PQRS will equal to 25 plus 27,95. This is equal to 52,95 units squared. Let's double check. OR x2 minus x1 all squared plus y2 minus y1 all squared. There we go. Okay, boys and girls, it's 10:36. We will do number 5 and 6. Wait. We'll do number 5 and 6 after the break. Guys, we're going on break. We will return at 11:15. We will return at 11:15. Enjoy your break, guys. Onliners, enjoy your break.
Ibulumko, one ko.
Come on, guys. Come on, come on, come on. Manyano. Buyani, buyani, pelili break. Tembelihle. Kenani phakathi. Naw Miss Bacela uzonibona. Izani, izani, izani. Bulumko na ku Mr. Bly uzonibona. Eh? Yeah, nzazi. Luhlaza. Izani, izani, izani. Masile phaya phezulu buyani, 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 dala nicula. Hey, niyaphi? 30 minutes yonke beninayo for ukwenza loo nto. Izani, izani. Anilibambi ixesha wani ngabantu be-maths late. Ufuna azokuthatha ngo? Exactly. Kanye ufuna azokuthatha? Singani ngambiza uba azokuthatha la mfana. Cause ibreak iphelile. Bhuti waseJoe Slovo bethi keyboard please. Wakwamfundo man. Itsho kabuhlungu endlebeni. Xa ungayazi awuyazi. Benendibizela? Ongo-1. Abantu abafotileyo if unefowuni engu-type C ungazi uzoyithatha ipicture yakho andizoyenza nto. But ba une-iPhone leya yakudala le itshajwa ngele nto ngecephe asinayo ke ngo. But une-iPhone le intsha ngu-type C so ungaza nayo. Ne-Android engu-type C not u-type B. La charge afuna ubeka iketile phezu kwefowuni izosebenza. If uno-type C ndiyatsho nje. If awuna-type C then unayo i-Bluetooth. Zakusendela i-Bluetooth. Ndikuvile kaloku. Kaloku ndithenza kwenzeka. Ufuna undibetha ngo? Oh, okay, i-pictures enizozithatha ngelunch ne? Xa nigqiba utya ilunch phaa then ungaza but not ngoku. Yeah.
Hey, okay. We back. Onliners, how's our onliners? We just waited for all the learners to get back here into the hall. Let's get going. We are in round 2. We're finishing up the analytics. Then we're going into trigonometry, the big section. Yes, the big section. And I'm going to show you trigonometry from the beginning. We're going to do everything in trigs. Let's continue. This is where we ended up before break. Let's continue, guys. Let's continue. So we finished the area of triangle PQRS. Let's go here. I want to finish this up before we go into trigonometry. Okay. So here we go. The equation of a line parallel to PS. Welcome, onliners. Are we back? Khalid, how's our onliners doing there? Talk to us. Hit us up in the comments. We are back, guys. I know it's a Sunday, but this is exam season. It's exam fever. This is time to sacrifice. So let's go. Right, the equation of a line parallel to PS. Now, PS is a straight line. It got no gradient. It's going through passing through R. Now it's only 2 marks. Guys, so it's very easy. These 2 lines are parallel. So the answer for this is x equal to. There's your final answer for that one. It's as simple as that. It's a straight line going through 2. It's parallel to that line. And this line here is 90 degrees. That's 90 degrees. It's a straight line. Where did I get the 2 from? From here. R's x coordinate. It's a straight line. Just to show you again, here we go, here we go, here we go. We got that line there. That is -7. This is a straight line going through 2. We got it from this point, R2 and -5. Khalid, you want to keep those learners at the back quiet there? Right, the learners who are coming in, please, you coming in, be quiet. Shh. Here we go, here we go, here we go.
Cela singangcole back Luhlaza nemasile phaya back please. Especially
Okay.
aba flight late TV.
We're erasing this. We're done with that. Let's go, let's go, let's go. The equation of a perpendicular bisector of QR from S. Perpendicular bisector. Perpendicular means 90 degrees. Bisector means to the midpoint of the line. So here we go. I'm just doing it here on this side here. Let's do it in a different color. From S, this is S. That is S, -7, -1. Shh. Thank you, thank you. Perpendicular bisector from there to there, that's 90 degrees to the midpoint of this line. Perpendicular bisector. Maniano, are you following? You understanding? Perpendicular, what does perpendicular mean? 90 degrees. What does bisector mean? That this line goes to the midpoint of QR. Are you guys with me? So let's first find out what is the midpoint of QR. So now, the midpoint of QR, I'm answering question number 6. The midpoint of QR, we all know, x1, x1, so it's actually here on here, so it's x1 plus x2 over 2. y1 plus y2 over 2. So this will give me -2 plus 2. That will give me 0 and -0.5. This point is 0 and -0.5. Now we want the equation of this line. We want the equation of that line. So firstly, let's work out the gradient. The M of the bisector. The gradient of the bisector is y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. That's -3 over 2 divided by 7. Let's work that out on our calculator. -3 over 2 divided by 7 minus 3 over 14. So this is the M of this line. The M of this line is -3 over 14. Now we want the equation of the line. That's why there's so much of work in it. Why so much work? What was the first thing they wanted? The midpoint, because it was bisector. Now we got the gradient of the line. Now that we got the gradient of the line, now we need to find the equation of the line. Now let's find the equation of the line. So now we can use that formula again that I showed you, y minus y1. Therefore, the equation of the perpendicular bisector is going to be what? Y minus y1 equal m into x minus x1. So we can use any pair of coordinates. Let's use a 0 and negative a half. Let's use the point 0 and negative a half. So y minus minus a half, y plus a half is equal to m. We found the m of this line, minus 3 over 14 into x minus 0. So y plus a half is equal to minus 3 over 14. X minus 0 is x. Now take the plus half on that side. Y equals minus 3 over 14x minus half. And there we go. So that's your final. So you'll get 5 to 6 marks for that. Some serious calculation. Some serious calculation, but at least you know what to do. You're going to need this for grade 10, 11, and 12. Onliners, how are we doing? Onliners, are we good? Beautiful. We now go into trigonometry. Now I'm going to explain to you trigonometry from the beginning because many of you got introduced to trigonometry for the very first time this year. All of you. Right, quiet. Thank you. Let's go. Let's put the heading trigonometry. Now, if you listen to what I say and if you follow my train of thought, I promise you, you won't have a problem in trigs. Shh. At the back. There's a lot of noise coming from the back there, guys. Thank you. Right, let's go. What is the meaning of trigonometry? Trigonometry deals with triangles. And this is the solving of. Now, trigonometry, the solving of triangles. For grade 10, you're only solving 90-degree triangles. That's all you deal with. You don't deal with non-90 degree. You only deal with right angle triangles. What do you do? Right angle triangles. Now, what do we mean? What do we mean when we say we are dealing with or solving 90-degree triangles? Okay, here we go. Okay, so we have a 90-degree triangle. Here we go. We got a 90-degree triangle. Now, if this is triangle PQR, and I told you that this is 20 degrees, and I gave you one side only, 3. If you didn't have trigonometry, will you be able to find the other 2 sides? No. You can't use Pythagoras because Pythagoras we need 2 sides to find the 3rd side. So this is what trigonometry is all about. Trigonometry solves sides by being given by given angles, or solve angles by given sides. You wouldn't be able to do this any other way. This is what trigonometry is all about. We're solving a 90-degree triangle. And what do we mean by solving? We're either solving sides by being given angles, or angles by being given sides. Pay attention to this. It's going to get intense just now. This is still the basics. I'm still introducing the topic to you. Okay, now pay attention. So in any triangle, the first thing to introduce the topic to you, the unknown angle, we don't call it X, Y, Z. You can call it X, but we call it angle theta. It's like X, Y, Z in algebra. It's an unknown. Right. So unknown angles in trigonometry, we call it angle theta, or we call it angle beta, or that sign there is angle alpha. Grade 10s, I need absolute silence. Right. The first thing we do in trigonometry, after you are given a 90-degree triangle, this angle theta, beta, alpha is called our reference angle. Why is it called reference angle? Because we're referring to it. So whenever I say the reference angle means which angle are we referring to? With reference, with respect to which angle? Okay. Step number 1, when you are given a 90-degree triangle, the first thing you do, the side opposite your reference angle is called your opposite. The side opposite your 90-degree, you all know, is called your hypotenuse. And then the remaining side is called your adjacent. So in order to solve triangles, whenever we are solving triangles, 90-degree triangles, especially or only 90-degree triangles, we use, you all know, SOHCAHTOA. These are ratios. Sine of angle theta is equal to opposite over hypotenuse. Cos of angle theta, it's the same angle, is equal to adjacent over hypotenuse. And tan of angle theta is equal to opposite side over your adjacent. These are your trig, what we call trig ratios. Sine, cosine, tangent. Sine, cos, and tan. Right, grade 10s. Take all this down. This is the background knowledge. We're now going to go into the actual solving using this. Did you guys do the Cartesian plane in school? ASTC? Good. We're getting to all of that. You did reciprocal functions, the opposite of cosec, cosecant, secant, SEC, sec, and cotangent. We're going to get to that. Come grade 10s, work with me here. Let's get through this. Right, let's start. Okay, let's give you a triangle. Any triangle. Grade 10s. All right, I'll wait for you to settle down. I need absolute silence. Khalid. I see there's still learners walking in here from break. Really? You took a full hour and a half break. Well done. You'll pass tomorrow, don't worry. Right. Here we go. Now, if this here is angle theta, and this is triangle ABC, right? If this is 5, that is 3. Question number 1. Find BC. Question number 2. Find sine theta. Find cos theta. Find tan theta. And the last one, find angle theta. No, and then the next one, find angle A. Now this is very basic. We're going through each one from the beginning. Let's answer question number 1, quite easy. We're going to use Pythagoras. So 5 squared is equal to 3 squared plus BC squared. Square on the hypotenuse is equal to the sum of the other 2 squares on the other 2 sides. So 5 squared is 25, 3 squared is 9, plus BC squared. 25 minus 9 is equal to BC squared. 16 equals BC squared. Square root of 16 is equal to BC. So BC is equal to 4. There we go. BC is equal to 4. That's BC. Right, you all done? With Pythagoras, that's very simple, straightforward, 3 marks. Sine theta, 2 marks. Cos theta, 2 marks. Tan theta, 2 marks. Theta, 2 marks. A, 1 mark. 3, 4, 5, 6, 7, 8, 9, 10, 11. In this case, 12 marks. This is basic. Right, let's go. Let's answer question number 2. Sine theta. What is sine according to Sohcahtoa? Opposite over hypotenuse. So let's go to our diagram. That's our reference angle. That's your opposite. That's your hypotenuse. That's your adjacent. So sine theta is opposite over hypotenuse, 3 over 5. They can tell you to 1 decimal place, 0,6. Number 2, cos theta. Adjacent over hypotenuse. Adjacent over hypotenuse, 4 over 5, which we all know is 0,8. The next one, tan theta. Opposite over adjacent, 3 over 4. We all know 3 over 4, 3/4 is 0,75. That's a 0, not theta. 0.75. There we go. We're done with that, done with this, done with this, done with it. Right, finding angle theta. Whenever we're looking for an angle, we use the shift key on our scientific calculator. So now we want to find angle theta. We want to answer question number 3, where we want to find theta. So you can use sine, cos, or tan. It's the same angle. You can use any trig function. So I'm going to say sine theta is equal to 3/5. Sine theta equals 0.6. Theta is equal, because I'm looking for an angle, I use the shift key on my calculator. So say shift sine, shift sine. Make sure your scientific calculators are on degrees on the top. There must be a small d on the top. If not, reset your calculator. Make sure that you have degrees. It says d. So now let's go. Shift sine 0.6. What do we get? 38.869. And they say, let's say they said to 1 decimal place. So theta is equal to 38.9 degrees. The last one, find angle A. We got 90 degrees. We got 38.9. What do we know about sum of angles of a triangle? To how much? Right, so let's find angle A quickly. This is all easy stuff. So angle A is 180 minus sum of angles of a triangle. So angle A equals, let's go, 180 minus open brackets 90 plus 38.9 close brackets, 51.1 degrees. And there we go, we've solved the triangle completely. We got all the unknown angles and all the unknown sides. Okay, I'm erasing this one. I'm going to give you one more to do, but I'm putting it in a different direction. So I'm going to give you a 90-degree triangle looking like that, like this, like that. Let's be interesting. Let's do this. Let's tell you that is 90, and I tell you this is also 90. This is P, Q, Q1, Q2, R, S. I tell you that this is angle theta here. Right. This is 5. That is 8. That is angle alpha. Right, let's have fun. Now, there are three 90-degree triangles there. There's the big one and the two small ones. Right. Question number 1. Find PR. Question number 2. Find angle theta. Question number 3. Find angle alpha. Question number 4. Find QS. And question number 5. Find the length of PS. Mark allocations. Find PR, 3 marks. 2 marks. 2 marks. 3 marks. 3 marks. 3, 6, 9, 10, 11, 12, 13 marks on this diagram. Let's all do it together. Khalid, those learners there at the back are very noisy. There's a lot of noise coming from the back and it's disturbing me here in the front. Guys, mathematics requires concentration because you need to analyze. That's why it's called analytics, trigonometry. The entire mathematics, you need to focus. If you're just seeing people writing numbers, it will make no sense to you. And maybe that's all you're going to see in the exam, a whole lot of numbers. And you're going to write whatever comes to your head. And they're going to give you whatever mark comes to their head. And you shouldn't be surprised. Right, let's go. Find PR. So we want this here. So we're going to look in this triangle. So to answer question number 1, I'm looking at in triangle PQR. Right. PR, we got a side. We're going to use Pythagoras. 8 squared is equal to PR squared plus 5 squared. 64 equals PR squared plus 25. 64 minus 25 equals PR squared. PR squared, and you can write Pythag. Guys, it's very irritating, honestly. So PR squared, 64 minus 25. 64 minus 25 gives me 39. So therefore, PR is equal to the square root of 39. That's square root 39. You can leave it like that. They don't tell you to any decimal places. Leave it in third form. Okay, find angle theta, the second one. Find angle theta. Now we got all 3 sides, so we can use sine, cos, or tan. I'm going to use sine. To answer question number 2, I'm going to say sine theta is equal to 5 over 8. Opposite over hypotenuse, SOHCAHTOA. So theta equals, let's use a shift key, shift sine 5 over 8. 38,7. Here we go, 38,7 degrees. Now you know that's 90, that must also be 90. Done. Let's do number 3, angle alpha. Angle alpha, we know in the big triangle that's 90. So I'm just going to say in triangle. We're telling the person who's marking, look in triangle PQS. The big triangle. Right. That's 90, that's 38,7. So we can use sum of angles of a triangle. So alpha is equal to 180 minus 90 plus 38,7. Sum of angles, you can write your reason on the side, sum of angles of a triangle. So alpha equals 180 minus 90 plus 38,7. 51,3. Here we go, 51,3. 12:30. 12:30, 12:35. Maybe 12:40. Maybe 1 o'clock. 12:35.
Guys, please let us not disturb the tutor at the back. Please behave yourself.
Right, here we go. The next one, find QS. Where is QS? Here's QS. Now let's look at this triangle. That's our reference angle. Opposite, hypotenuse, adjacent. I'm going to use sine. Sine 51,3 is equal to my opposite over my hypotenuse. So it's RQ over my hypotenuse is QS, what they want me to find. So sine 51,3. What is RQ? Don't we have RQ? 5 over QS. Now how do we make QS the subject of the formula? So this is over 1. So what we can do, watch here, it's an equation. I want QS on the top and that at the bottom, so I can flip this side. Or you can cross multiply, it's up to you. What you want to do, cross multiply or flip both sides? All right, you want to cross multiply. All right, let's cross multiply. Bring QS to the top. QS sine times sine 51,3 is equal to 1 times 5 is 5. And I want QS on its own. So divide by sine 51,3. What I do on the left, I do on the right. That and that will cancel. QS is equal to, go to your calculator, 5 over sine 51,3, close brackets, boom, 6,4. And QS is a side, so it's units. It's not an angle. An angle is in degrees. A side is in units. So now we get 6,4. Now there are so many ways to find PS. There might be about 4 different ways to find. Any of the ways that you use will be accepted. How are we going to find PS? We can either work in the small triangle and find RS and then add RS to 39. Or one way, I can look in the big triangle and PS is the hypotenuse. I can use Pythagoras. It's up to you. I say let's use Pythagoras. What do you say? So let's say PS squared is equal to 8 squared plus 6,4 squared. I'm looking at triangle PQS. Pythag. So PS squared equals 8 squared plus 6,4 squared, 104,96. So therefore PS is equal to the square root of 104,96. PS is equal to the square root of 104,96. 10,24 or 10,2 units. And there we go, we get our full 13 marks for that. I've combined, in fact, there were 3 different 90-degree triangles in one shape. Okay. Now, what do we need to know in trigonometry? Now, this is like the basics. Watch here. Right, what questions are you going to get in trigonometry? And this is very important. What type of questions? Right, number 1, you're going to get to solve a triangle. A 90-degree triangle using SOHCAHTOA. Number 2, you're going to need to simplify using a calculator. Number 3, you're going to get, did you guys do special angles in school? So then you're going to have to do simplify without the use of a calculator, which is your special angles. Then you're going to get what we call reciprocal functions. Then we're going to have equations where we're solving for theta or solving for x. Did you guys do angle of elevation and depression? No? Huh. So this is generally what you're going to see. Right. This is trigonometry. So we did that. Let's do number 2, simplifying using a calculator. Right, so the question now will say simplify and give your answer to 1 decimal place. The minute they say 1 decimal place, it means you can use a calculator. Number 1, 4 cos 50. Number 2, sine squared 25 plus cos squared 18. Give me a second. Tan of negative 58. Oh, there's one more here called substitution. Right. Tan 140 minus sine 350 divided by cos squared 48. Now this is all easy, it's all straightforward, you have to use your calculator. So I'm giving you 4 examples of simplifying. So we've done the first one, solving a triangle. We're on to the second one. We're going to do all of this. We're going to do examples of all of this. When we're done with this, we're done with trigs. Right. 4 cos 50. Go to your calculator. Say 4 cos 50 equals 2,57. But to 1 decimal place, 2,6. 7 changes the 5 to a 6. 1 decimal place, you look at the second digit after the comma. Right? Let's go. Sine squared 25. So basically, guys, this is how you do it. When you're putting it in your calculator, you're going to say sine 25 squared plus cos 18 squared. That's how you'll punch it on your calculator. So sine 25 close bracket squared plus cos 18 close bracket squared 1,08 correct to 1 decimal place, comma 1. Remember the angle is sine 25. Agreed? Let's do number 3, tan of negative 58. That's so easy. Go to your calculator, just plug it in. Tan negative 58, close brackets, boom, minus 1,6. So we're done with all of this. And the last one I want you to do on your own. Number 4, let's check if you can do it on your own. Then we're going into, in fact, let's do reciprocal functions first. Oh no, let's do simplify without the use of a calculator, your special angles. Right, number 4, tan 140 minus sine 350 all over cos squared 48. Put it into your calculator. Fraction tan 140 close brackets minus sine. The calculator will open up the bracket. You'll say 350 close brackets. Come down. Now we'll say cos, open brackets, cos 48, close brackets, squared, close brackets. In fact, when you're putting this on the calculator, you're going to put it like this, tan 140 minus sine 350 over, you're going to open up the bracket, then you're going to write cos, open bracket again, cos 48, close bracket, squared, close bracket. That's how you're going to plug it in onto your calculator. Or, let me just see, can we avoid that? If I just put divided by cos 48, cos, no. Cos 48 squared. No, it's fine. Rather than don't do it that way, just put it in like this. Write it as cos 48 and then press the x squared button. It will give you a squared there. That's the easier way to do it. And we get minus 1,486 to 1 decimal places minus to 1 decimal place minus 1,5. Right? Good. Well done. Now our special angles. Let's do our special angles. We on point number 3. It's 12:09. At 12:35, you'll go for your lunch. You'll go for lunch. You'll come back and then we'll continue again. Right. What are your special angles? 30 degrees, 45 degrees, 60 degrees. 90, you know 90, 180, 270, right? And 360. But the ones that we worried about is 30, 45, 60. You all know that sine 60 is root 3 over 2. Sine 30 is equal to a half. Cos 60 is equal to a half. Cos 30 is equal to root 3 over 2. We know that sine 45 is equal to 2 over root 2, or, no, it's root 2 over 2, I think. Root 2 over 2, or 1 over root 2. That's sine 45, cos 45. It's the same. We know that tan 60 is equal to root 3. And we know that tan 30 is equal to root 3 over 3, or 1 over root 3. We also know that tan 45 is equal to 1. Remember this, memorize this. You're going to need this for grade 10, 11, and 12. So remember this. Sine 60 is root 3 over 2, so sine 30 is the half. Cos 60 is like sine 30, is the same. And sine 60 and cos 30 is the same. Cos 45, sine 45, 1 over root 2 or root 2 over 2. Tan 60 is root 3, tan 30 root 3 over 3, tan 45 is 1. Khalid, how's our onliners doing there? Everybody all in, the big shout out here.
We have someone oh, it's Awonke. Awonke said your happy birthday. Are you here? Ulapho Awonke?
Yo, we got somebody on their birthday joining maths. Let's give him a nice round of
applause. To you. Hip hip. Hip hip.
Okay. Okay, you've taken down your special angles. Okay, pay attention, pay attention. Now, I'm now going to show you reciprocal functions, and then we're coming back to simplifying with reciprocal functions. So, we're going to come back to simplifying. We're now on reciprocal functions.
Elas Pinas Sole, please. Please.
Right. Reciprocal functions, cosec of theta is 1 over sine theta. Write this down. And you'll only use this in grade 10. Grade 11 and 12, they drop your reciprocal functions. You don't get to use it. Only in grade 10, you get to use cosecant, 1 over sine, secant, 1 over cos, cotangent, 1 over tan. These are what we call reciprocal, the opposite functions. Now, just to show you how we use it, if they say sec theta, secant theta, quiet, is equal to 2. Solve for theta. I'm showing you how to use your reciprocal functions. Okay. Secant is what? 1 over cos theta is equal to 2 over 1. I just converted secant to 1 over cos. Pay attention. Right. We want cos on the top. You can cross multiply if you want. But look what I do. I normally just flip this side. I flip that side. So I bring cos theta to the top. So cos theta over 1 equals 1 over 2. Boom. You get the same thing. It's an equation. If you flip the left, you flip the right. So now theta is equal to shift cos a half. Shift cos a half, 60 degrees. We use the shift key on our calculator. Shift cos of a half, we get 60 degrees. Now I'm going to give you some crazy problems to do to simplify without the use of a calculator. Using your special angles and reciprocal. You got to show you special angles. So it's going to start getting. Are you ready to go underwater? To go swim with the sharks? Okay. This is called Shark Tank. Okay. Here we go. The question says simplify without the use of a calculator. Number 1. Tan squared 45 minus cosec squared 45. Number 2. 3 tan squared 30 minus a third sine squared 60. Number 3, tan 45 times sine 30 times cosec 60 all over sec 30. We still have to do the diagram. I forgot we still have, besides substitution, you got to do the diagram, the cast diagram. Add on one more topic, the cast diagram. The Cartesian plane. We're still going to get to that. Usually the cast diagram is question number 1. Must I do number 1 for you? I'll do number 1. You can do number 2 and number 3. How about that? So let's do number 1. So this is equal to tan 45 squared minus cosec 45 is 1 over sine 45 squared. So let's go to our calculator. I know they say without the use, but I mean, your calculator gives it to you in third form. So you know tan 45 is 1 squared minus 1 over sine 45 is 1 over root 2 squared. Now do the algebra. They want to see that you know how to simplify. Use algebra now. Come on. So 1 squared is 1 minus 1 over 1 squared is 1 over root 2 squared is 2. So I'm moving over here to the side. So this is 1. This is equal to 1 over 1 minus. How do I get rid of this 2 at the bottom here? How do you get rid of that 2? You multiply it by 2 over 1. Yes or no? What we do to the denominator, we do to the... So 1 times 2 is over 1. Yes or no? So basically this is 1 minus 2. And 1 minus 2 is how much? Negative 1. How's our onliners there, Khalid? Are they still surviving? Are they managing? They writing this week?
There's somebody complaining that the girls at the back you're disturbing. Please, guys. Please.
Do number 2, do number 3 on your own. Do number 2, do number 3 on your own. We're not going to finish all 7 before lunch. We're going for lunch very soon. Number 2, 3 tan squared 30 minus 1 over 3 sine squared 60. 3, what is tan 30, guys? Root 3 over 3 or 1 over root 3, am I right? Squared. Minus 1 over 3. What is sine 60? Root 3 over 2 squared. Yes or no, guys? Now let's all do without the calculator. Without the calculator, they're giving you 5 marks for it. So they want it step by step. Right. So this is 3 into 1 squared is 1 over root 3 squared is 3 minus 1 over 3 into root 3 squared is 3. 2 squared is 4. That's over 1. 3 times 1 is 3 over 1 times 3 is 3 minus 1 times 3 is 3 over 3 times 4 is 12. 3 over 3 is 1 minus 3 into 3 once, 3 into 12, 4 times. So this is equal to the number 1 is 4 over 4 minus 1 over 4 over denominator 4 minus 1. Your answer is 3 over 4. Right? Didn't get it right? Do the last one. Do the last one. We're then going to go into substitution after this. Let's do the last one, guys. Tan 45 is 1. Sine 30 is a half. Cosec 60 is 1 over sine 60. Divided by sec 30 is 1 over cos 30. Your reciprocal functions. 1 times a half is a half times 1 over sine 60 is root 3 over 2 divided by 1 over cos 30. Cos 30 is sine 60, which is root 3 over 2. Okay, let's go. That's a half times. We did this yesterday. How do you get rid of root 3 over 2 times 2 over root 3? What you do to the denominator, you do to the numerator. Yes or no? That and that will cancel out. You're left with 2 over root 3. Divided by we multiply this by 2 over root 3. What we do to the denominator, we do to the numerator times 2 over root 3. Right. Now we need to get rid of this 2 over 3 here. So we multiply that by root 3 over 2. Reciprocal, the opposite, the inverse. What we do to the denominator, I do to the... There we go. Now we can cancel what's common. 2 and the 2, root 3 and the root 3. 1 times 1 times 1 is 1 over 1 times 1 times 2 is... Do you guys want one more like this? No? Come, I give you one more and you go for break. You go for lunch. Right. Last one before break. Last one before break. Simplify without the use of a calculator. This is the last one. We're going to come back at 1:20. We're going for lunch now. It's 12:30. By the time we're done with this, it's 12:35. We'll come back at, say, 1:20. We'll continue with this right through until about 2 o'clock, 2:15, and then from 2:15 to 3 o'clock, Euclidean. We're about to go for lunch. This is the last one before lunch. Shh. Hey, those at the back. Khalid, the learners at the back are going crazy. I don't know for what. Sine 30. Sine 30 is a half squared. Sec 45 is 1 over cos 45 squared. Cosecant is 1 over sine 45 divided by tan 45 squared. Half squared is 1 over 4. Now 1 divided by cos 45. You can even do it 1 divided by cos 45. Your answer on the calculator will give you √2. As long as you use √2, no decimals, you can cheat legally. 1 over sine 45, also √2. Check on your calculator. Tan 45 is 1 squared. I'm going to move over to the side. That's 1 over 4. √2 squared is 2. Then we're left with √2 all over 1. 2 times 1 is 2 over 4 times √2. 2 over 4 is a half √2. You can leave it like that, or you can say that's over, multiply by that, or your answer is √2 over 2. One, 2, 3, 4, 5, 6 marks. Okay, 12:33. Boys and girls, it's time for lunch. Your food has arrived. We're taking a break until 1:20 p.m.
Abantu bezithombe ne. After nifumene lunch, then uze nefone type C. Type C.
Okay, guys, enjoy your break. Enjoy your break. We will resume at 1:20. Enjoy for the graveyard session.
Workshop coming to you live from Luhlaza High School. With me now, as is the custom, I've got a host of students, a cohort of students coming from different schools that are currently on the ground. They will be chatting to us as to what exactly motivated them to come here today and what is it that they want to do after high school. And firstly, we're going to have a student from Ecosat that will be talking to us. A student from Ecosat, come a little bit closer and talk to us. What motivated you to come here today? And firstly, your name.
So good morning, everyone, and the onliners. So it's not working. So my name is Zusake, and my surname. My name is Zusake, and my surname is Bono. Firstly, what motivated me to be here? So, I want to focus hardly on mathematics because I know it is the key to education, and I think it's the key on understanding the other subjects, because even science includes mathematics and the others like technology, and we focus hardly on technology at my school. So if I'm weaker in mathematics, there is no hope in other subjects. So I have on mathematics harder so that I can cope on other subjects at school. So it's what motivated me to learn about mathematics and importance of mathematics.
Have you enjoyed the sessions this morning? And I understand that you were here even yesterday. Did you enjoy the sessions?
I did enjoy the sessions even from yesterday, but my schoolmates were discouraged and they had many complaints, but I was not discouraged. I was encouraged because I know that I learn more in mathematics, and I love mathematics, and I look forward on excelling and doing better.
What is it? Earlier you spoke about if you are weak on mathematics, then it's difficult to advance yourself, in terms of science. What is it that you want to do when you go to university in 2 years' time?
Since I'm very focused on science, so I will do hard on science in university. I'm not sure enough what I will be after university, but I think the way I do at school will decide what I choose to be after university. But I'm looking forward on be the doctor who inspects things like medicine, a medical doctor, yes.
Just before I let you go, do you have a shout out message perhaps to someone who may be watching?
The only thing I have to say is education is the key to success. And whatever the others say against education, you don't have to listen to them. You don't have to accept the bad things they say. Just just be educated intentionally and focus on what you think will be best for you and your future. Yeah.
Thank you very much. And this is a student from Ecosat saying that you don't have to be discouraged. You have to try by all means to focus on education. And now with me is a student from Ezola Business School who will be chatting to us as to what exactly they want to do in university and what has motivated them to come here today. What is your name and what motivated you to come here, Namhlanje?
Greetings to you all. My name is Tando Makolwa. I am from Zola Business High School. What motivated me to come today was to look for other resources, not to only rely on my teachers and Kevin Metz and other pages. I watch mathematics onto YouTube. So I wanted to see and to learn from other people how it's done. And that's what motivated me.
Have you enjoyed the sessions this morning?
Yes, I have enjoyed the sessions even when there was a little bit of distraction, but we managed, and yes, I did.
What is it that you want to do? I understand that you come from a business school and perhaps your intentions are business centered. But just to be specific, xa use university, what is it that you want to do there?
I have my heart set on in become of accounting, since I'm currently doing accounting. So yes.
If you're talking about a BCom of accounting, then the best school for that obviously will be the University of Western Cape. Are you eyeing any other university?
No, I recently went there on the 9th of May for their open day, and I'm not gonna lie, my heart felt that was home. So I will try and make sure that I meet the requirements for becoming accounting for it.
You are hearing it at home live from Luhlaza High School. What is it that you want to do? You know, in 10 years' time, where do we see you? Because in 10 years' time, obviously, you won't be in university, or if you decide to advance, your education further, where do we see you in 10 years?
If I don't have PhD in accounting, then I don't know where I see myself, because that's where I have my heart set on.
Guys and girls, we've got a professor next to me from Zola Business School. Thank you very much for joining us. But just before I let you go, do you have a shout out message for anyone who is watching now or who will be watching later?
I would like to shout out to Mr. Mthobulo, our mathematics teacher, and I would like to say him that please, no matter what we do, no matter how wrong we do, you please don't give up to us. You are our hope and our light.
That's the message. Thank you very much for joining us this afternoon. And next, now we have a student from MRC in Side B who will be chatting to us. I believe her name is Elam. Elam, talk to us. What is your name and what has motivated you to come here today?
Okay, so igama lami ngu-Ella Magazi ndisuka eMasile. I think into enimotivateyo namhlanje kuba I think ufumana into from different person kuyanceda we understand it better, like ungasoloko uthembele ngomisi wakho, like, and then like ufumane like yeah, from a different perspective from abanye abantu understand ngcono. Yeah,
Elam, uzi enjoyile isession namhlanje?
so far I have enjoyed, I have no complaints. Yeah.
Elam, after grade 12 wakhe in 2 years time, uyokwenza ntoni university?
University ndizibona ndizostudisha medicine.
Why medicine? Why ugqirha? And xa ungugqirha ufuna uba ngowantoni? Ukhona wamazinyo, ikhona i-gynecologist, ikhona i-surgery. So uyaphi wena phaya?
Mna andikabikho sure kakuhle uba ndifuna uba ngugqirha wantoni, but all I know is that ndifuna uba ngugqirha because I love helping abantu. Ndayidevelopa loo nto ndisemncinci and ndayithanda i-maths and science. So
Wow. Nanku kugqirha bethunana ecal kwethu, uba unentloko i-pure maths ikwenzela intloko, uphakamise nje isandla sizambiza, akuncede, akubethe noba kungempama, ubuyele ezingqondweni. Guys, just before we let you Elam go, Elam, ikhona message mhlambi ofuna uyithetha maybe to i-class ka-2026 ezobe ibhala i-final exam for grade 12.
ndifuna ukuthi guys nisebenze ngamandla, ningagive up. Imfundo yeyona nto evula iminyango, ngumavula kuvaliwe. As siyazi ne-say ithi bana the education is the key to success. So yeah.
Thank you very much, Elam, for joining us. Elam Lowokiza from Emasile High School. And lastly, ultimately, we have a student from Emanyano. And there's a lot of students from Emanyano that are currently watching us here on the ground. So I want you to scream. Thank you very much for joining us. Tell us your name and why are you here this morning?
So my name is Umbasa Mjadana. I came here for maths tutoring. Yeah.
Have you enjoyed the session or has the session perhaps lived up to your expectations?
100%.
Talk to us about that.
About?
the expectations that you had that have been met by this particular workshop?
So I personally believe that coming from home, the main thing that inspired me was the plethora of knowledge that I wanted to seek here today. So I feel like I got exposed to various kinds of ways, and yeah.
Are you going to use the ways though? Because most of the time students learn new ways, but they're like, okay, I'm comfortable with what I learned from home.
I will definitely use them. Yeah.
What do you see yourself in 2 years' time when you have got your 4, 5, 6, 7 distinctions or even more? What do you see yourself? What is it that you want to do at university?
So I am torn between mechatronics engineering and actuarial science.
Nansi message ngena phaya iyabuza yintoni actuarial science. Mphendule.
So actuarial science, basically, in a nutshell, it is the study of risk management in the business field. It's a combination of accounting and mathematics.
Why yona?
Because I love how mathematics is so intriguing. You can never know enough of maths. So how intriguing it is, it just keeps you going.
It just keeps you going. Now, there's a lot of students that are watching you. You've got quite a fan base here today. I want you to give a message out to them as well as the class of 2026 from Emanyano, because Emanyano hasn't been in the first school, in the last few years. So kaba motivate about one.
Okay, so to the class of 2026, I would like to say that this is your moment to rise, embrace any challenges, seize the moment. The future is yours to shape, and I wish you all the best once again in your journey ahead.
A message to anyone now who is watching.
So what I would love to say is that never let your background dictate where you're going in life. Personally, even naxa ungena naseteksini udriver akakubuza uba usuka phi, uyakubuza uba uya phi. Meaning to say you must know where you're heading to, not the background.
Thank you very much for joining us this afternoon. We appreciate your time. And that's the message we are getting here today, that xa ungena eteksini udriver akakubuza uba usuka phi, kodwa ukubuza uba uyaphi, meaning that where you come from, your background does not determine your future. So it is Awqaf SA, the Grade 10 Pure Maths Workshop, coming to you live from Luhlaza. Do join us online. Do come here and make sure that you are with us this afternoon as Awqaf SA wraps up a 3-week series. We started with Grade 12 at Spine Road, and then we came with Grade 11 last week at Portland's High School. And now we are here at Luhlaza for Grade 10. Thank you very much for joining us. And that brings us to the end of today's interviews. We are back with mathematics. Now stay tuned. Thank you very much. Okay, guys, come in. Let us settle down. Thank you very much.
Okay. Let's go. Call everybody in. We're into the last session. Welcome back, our onliners. Welcome back, all our on-siters. Hope you had a wonderful lunch. Dude. Oh, yeah. Let's go. Okay, so we were done with this. This is where we wrapped up before break. Welcome back to all our onliners and all our on-siters. Let's get started. Call everybody in. Settle down. Let's start with substitution. We tell you if A equals 81 and B equals 36 copies. You can use a calculator. Use a calculator to find the following. Use a calculator to find the following. Okay, grade 10s, we're back in session. Let's go, grade 10s. Okay. Number 1. 10 squared a over 2. Number 2. 2 tan a plus sine b over 2. And let's do one last one. 2 sine squared a plus cos 2b plus tan a over 2. Here we go, guys. We are starting with trig substitution. We're then going to do trig equations, and then we're going to do using the Cartesian plane. Then we're going to do using a diagram, a real life diagram, and then that will bring us to the end of trigonometry. Then we start with Euclidean. Right, thank you. Guys here at the back, settle down. Right, let's go. Right, this is called trig substitution. You want to just turn the gain down a little. Okay, guys. Let's go, let's go, let's go, let's go, let's go. Right, so this is tan a over 2 all squared. This is equal to tan 81,4. So this is tan 81,4 over 2 all squared. Let's go to our calculator. Tan 81,4 over 2 close brackets squared. 10,93. Your answer is 10,93. That's the answer to question number 1. Let's go into question number 2. Guys, don't wait for me. If you want to try finishing them all up, you can try working on them already. Grade 10s, thank you. Start. I know some of you work quite fast. So you're done with question number 1. You can do question 2 and question 3. Go for it, guys. Grade 10s. Thank you. Let's do number 2. 2 tan a is 81,4 plus sine b 36,8 over 2. Let's go to our calculators. 2 tan 81,4 close brackets plus fraction sine 36,8 close brackets divided by 2 equals 13,52. And let's do the last one. This is 2 sine A is sine 81,4 squared plus cos 2 times B, 36,8 plus tan 81,4 over 2. Let's do all this one shot on our calculator. 2 open brackets. Sine. Or we can say 2 sine 81,4 close bracket squared plus cos 2 times 36,8 close brackets plus tan open brackets. Remember, it's tan A over 2. So tan open brackets fraction 81.4 over 2. 3,097, which is equal to 3,1. Right, so there we go. We're done with trig substitution. Let's go into trig equations. Now we're solving for theta in an equation. So we've done special angles. We've done reciprocal. We've used SOHCAHTOA. We've done substitution. We solved triangles. Now we're going to do trig equations and then the Cartesian plane. Okay? Right. It's going for 25 to 2 already. Before you know it, it's 3 o'clock and it's time to go home. Our 2-day workshop, our 2-day boot camp is almost coming to a close. You guys have done 2 days of non-stop mathematics. How nice. Okay. Put the heading trig equations. Right, here you are solving for x or solving for theta. Now, what you want to do, step number 1, you want to get it into standard form first. That's step number 1. What is standard form? It's a trig function of an angle, whatever the angle is, must equal to a fraction or a decimal. That is standard form. Now you use the shift key to find the angle. Now you solve for the angle. So get it into standard form. Get it into that form there. Then use the shift key to find your angle. Now last, you solve for the angle. It's done in these steps. Hey, grade 10s. Thank you. Right. We're going to do about 6 or 7 or 8 of them. So that once we do these, you have mastered them all. You'll see it in the exam. Hopefully there won't be anything in the exam that they can throw at you that we haven't done at the Awqaf workshop. All right? Okay. Let's start. Let us begin. Right. In all of these, right, let's go. Solve for x or theta. Question number 1. Right. Sine theta is equal to 0,3. Number 2. 2 cos theta equals 1,6. Number 3. Tan 3 theta, not tan cube, tan 3 theta is equal to 1,2. Number 4. Sine theta plus 10 is equal to 0,8. Number 5. 3 cos theta equals sine 55,3. Number 6. 3 sine x plus 10 minus 2 equals 0,1. And the last one, I think I should write it here at the bottom. Can you guys all see there on the screen? Yeah. So let's do number 7. Let's say 2 tan 2x plus 10 degrees is equal to 10. Right. So here's 7 equations to do. Here are 7 equations to solve. They're all slightly different, but they are all easy to do. We're going to follow it in that same, get it into standard form, use the shift key to get the angle, then solve the angle last. You solve for the angle last. So what did I say? Standard form. Use the shift key to get the angle, and then solve for the angle last. Shh. Thank you. At the back, you guys are making noise. You are disturbing everybody, please. Okay. Let's start. I'm going to do them all for you. Let's all start with number 1. Sine theta equals 0,3. Is it in standard form? Yes. Trig function of an angle equals a decimal or a fraction. So it's in standard form. So theta is equal to, go straight to your calculator, shift sine 0,3. 17, and let's say they tell you to 1 decimal place. Let's say for all of them, solve for theta to 1 decimal place. Right, so theta is equal to 17,5 degrees. That's number 1. Number 2. 2 cos theta equal 1,6. Get it into standard form. Divide by 2, divide by 2. So cos theta equals 1,6 divided by 2. Theta is equal to shift cos fraction 1,6 over 2. 36,9. Yes or no? All right. So we're done with number 1. We're done with number 2. Onliners, how are we doing? Are we back? Everybody all in? Okay, lovely. Let's do number 3. Tan 3 theta equal 1 comma 2. That's in standard form already. You can't divide by 3 and divide by 3. If this is a 1, that's your angle. So now shift tan 1 comma 2. So your angle is 3 theta is equal to shift tan 1 comma 2, 50,1944. 50,1944. Now we solve for the angle last. Divide by 3, divide by 3. So 50,1944. Now you divide it by 3. Theta is equal to 16,73 or 16,7 degrees. So here we go. Standard form. Shift key, solve for your angle last. We're done with number 3. Let's do number 4. Sine theta plus 10 degrees equals 0,8. That's already in standard form. Trig function of an angle equals a decimal. It's in standard form. Use the shift key. Shift sine 0,8. So what's your angle, guys? Angle is theta plus 10 equals shift sine 0,8, 53,13. Now theta is equal to take the 10 over, 53,13 minus 10, theta is equal to 43,13, 43,1 degrees. This is your angle. We're done with number 4. Let's put down number 5. 3 cos theta equals sine 55,3. So cos theta equals sine 55,3 divided by 3. So now theta is equal to shift cos fraction sine 55,3 close brackets divided by 3, 74,09 to 1 decimal place, theta is equal to 74,1 degrees. We're done with number 5. Let's do number 6. 3 sine x plus 10 minus 2 equals 0,1. Right, we only want this on the left-hand side. So take the minus 2 over 3 sine x plus 10 equals 0,1 plus 2. 3 sine x plus 10 is equal to 2,1. Divide by 3, divide by 3, sine theta plus 10 equals 2,1 over 3. So x plus 10, that's your angle. Shift sine, fraction 2,1 over 3 equals, whoa, 0,1 plus 2 is 2,1. 2 shift sine 2,1 oh 2.1 over 3 equals 44,4. So x is equal to, take that on the other side, 34,4. That's number 6. Do number 7 on your own. Not difficult. Not difficult. We're doing the last one. Let's hope you got the last one right. 210. 2x plus 10 equals 10. Divide the side by 2. Divide that by 2. We left with 10. 2x plus 10 equals 10 over 2 is 5. Did you all get that? Now say shift 10, 5. So you got 2x plus 10 equals 78,69. 2x is equal to 68,69 because I'm going to take this 10 over. Divide by 2, divide by 2. Here's your final answer. 34,34, 34,3 degrees. Guys, learn these 7. I promise you, you learn this. I don't think there could be any trig equation that they could give you that you won't be able to do if you've mastered the 7 I've done for you. Okay, you done? All right. Now let's do the Cartesian plane, where you have to draw the Cartesian plane. So now they tell you, let's do this one. Sine minus 4 over 5. If minus 5 sine theta minus 4 equals 0, and theta is greater than 0 but less than 270 degrees, find cos theta, find tan theta, find theta, find 2 sine squared theta minus 3 cos squared theta. No calculator. Now, many of you get confused what to do here. Right. I'm going to give you another acronym. We use what I call SCRAP. What do we use? Right. What does SCRAP mean? First S means get it into standard form and use SOHCAHTOA. So S, SOHCAHTOA, and S for standard form. 2, draw your Cartesian plane. Number 3, look at your restriction. R for restriction. where to draw the triangle. A is just n, so don't worry about that. And P, use Pythagoras to finish it. So we use scrap. Whenever we're drawing a triangle, we use scrap. What do we use? Right. This is the mental. Beautiful. So if you follow this, you'll never go wrong. So let's do the first S. Let's, in our answer, let's get it into standard form. So minus 5 sine theta equals 4. Sine theta equals 4 over minus 5. Sine theta equals minus 4 over 5. There we go. That's standard form. Pay attention. We're going to follow this strictly. We're going to follow scrap. What's after standard form? What must I do? SOHCAHTOA. Sine is opposite over hypotenuse. Yes or no? Right. So we're done with standard form. We're done with the S. Right. What must I do now? Draw what? Right. So let's draw it. Let's draw your Cartesian plane. Quiet. We know this is A, S, T, C. All positive. Quadrant 1, 2, 3, 4. Cartesian plane. So we drew the Cartesian plane. That's done. Let's look at the restriction. Now wait. Before we look at restriction, how do we determine where to draw the triangle? Now this is very important. If you pay attention here, you won't go wrong. Theta is greater than 0 but less than 270. That means theta could be there, there, or there. So put 3 ticks, 1 in each quadrant. But where is sine negative? From these 3 quadrants, all is positive here, so sine can't be negative. Sine is positive here in the second quadrant, can't be negative. So from these 3 quadrants, which is the only quadrant where sine is negative? Quadrant 3. So wherever you got 2 ticks, draw your triangle. And you always draw your triangle against your x-axis, never against your y-axis. Right. There's theta. Opposite over hypotenuse. What's our last step? Pythagoras. Let's use Pythag to solve for x. 5 squared is equal to x squared plus minus 4 squared. 25 minus 16 is equal to x squared. X squared is equal to 9. X is equal to plus or minus 3. Now it's to the left of 0. So it has to be negative 3. You can't go and put positive 3 there. Shh. Guys. Right? Good. Now only can we answer our questions. After applying scrap, what is, let's do cos theta. We just use SOHCAHTOA to answer these questions now. Cos theta is adjacent over hypotenuse. Adjacent over hypotenuse minus 3 over 5. Tan theta is equal to opposite over adjacent. Opposite over adjacent, minus 4 over minus 3, which is equal to 4 over 3. Theta. You can use sine, cos, or tan. I'm going to use sine. You can even use tan if you want. Tan theta equal 4 over 3. Let's answer question number 3. Tan theta equals 4 over 3. So theta equals shift tan 4 over 3. 53,13. Now remember, they're telling you it's greater than 0, less than 270. That means it's this whole angle here. So therefore, theta equals, from here to here is 180. From there to there is 53,13. So it's 180 plus 53,13, because it's in your third quadrant. Theta is equal to 180 plus 53,13. 233,13. Right, let's do the last one. Yo, it's 2 o'clock already. Can you believe it? Learn this. Okay, here we go. The last one. 2 sine squared theta minus 3 cos squared theta. 2 sine theta squared minus 3 cos theta squared. 2 sine is minus 4 over 5 squared, minus 3 cos is minus 3 over 5 squared. 2 into negative 4 squared is 16 over 25, minus 3 into 9 over 25. That will give me 32 over 25 minus 27 over 25. What do I get? 32 minus 27, I get 5 over 25. I can simplify that. My answer is 1 over 5.
Kwamfundo emveni kwe-TV. Please, guys.
Thank you.
People are complaining about you.
Okay. Last application. Last application. Now let's see how, oh wait, there's one more type like this, right? But there's a reason why I'm showing you, because you're going to be using it in grade 10, 11 and 12. Guys, whatever notes you got today, you don't lose it. Whatever we're taking down now, you're rewriting your own study guide. Do not lose today's notes. Memorize everything we have done between yesterday and today. Okay, here we go, guys. I hope you took a nice photo of me. Not those crazy ones. Come, take a nice one. Let's see. Yeah. And put filter, eh? Make me look handsome. Right. Here we go. If sine 46 equals A, if sine 46 equals A, find the following in terms of A. Wait, stomach in, chest out. Right, number 1, cos 46. Number 2, tan 46. Learn this. Shh. Number 3, sec 46. Number 4, cosec 46. Number 5, cot 44. Sine 44. Here we go. 2, 4, 6. No, we'll make that. Okay, 2, 4, 6, 8, 10, 12 marks. How many of you know how to do this? Ask a grade 11 or 12. A grade 11 or 12, if they're watching this or they'll smile because they see this in every paper till grade 12. Same structure of a problem. Only thing, the level of difficulty of the questions based on this will be slightly higher. So you got to know it. Everything you do now, everything we did this weekend, you're going to be using it over the next 3 years. You don't forget anything. You master everything. Right, come and show you what to do here. Shh. Hey, who's talking at the back? Right, let's go. Question, answer. Guys, watch here. Step number 1, standard form. SOHCAHTOA. Cartesian plane. Restriction, no restriction is given. 46 is our reference angle. And Pythagoras. So we use scrap again. What do we use? Why? Because we have to draw a diagram. Pay attention. So if this is 46, opposite over hypotenuse, A over 1, we need to solve for x. 1 squared equals A squared plus x squared. We're solving for x. 1 minus A squared equals x squared. X is equal to the square root of 1 minus A squared. So x is the square root of 1 minus A squared. You have to do this. If you don't do this, you can't answer any of the questions. You lose all 12 marks. So I'm just going to write compulsory. So amazing that in such a short period of time, we have mastered the whole of trigonometry for the entire year. Everything we did today is everything you need to know for trigs. So let's go. Cos 46. Now we use SOHCAHTOA. Cos 46. Adjacent over hypotenuse. So that's my opposite. That, let's put it in a different color. Opposite, hypotenuse, adjacent. This is A for adjacent, not A, the alphabet. So adjacent over hypotenuse, 1 minus, square root 1 minus A squared over 1. which is still the square root of 1 minus a squared. Anything over 1 is still the same. We just use the diagram now. I see some learners are not even writing. All they're doing is they're processing. They're just looking. I wish I had such a super memory like some of you. I mean, you people are gifted, some of you. No, really. No, really. I feel cheated in life. I feel God didn't give me the same brain like you. I mean, you just the whole 2 days can just sit there, just watch everything, and the numbers just start making sense to you. You don't need to write anything. Let me tell you something. You're going to fail. I like the learner who's sitting back like this, relaxing. Yo, it's a Sunday afternoon, chill. He's thinking, what's he going to be doing with his bras? He's watching, no, don't worry, Mr. K, I'm sharp. I sorted the whole thing out in my head. You sorted it out in your backside. You will fail in that exam. Nicely, beautifully, you will fail. Imagine mathematics must still sit with a pen, paper, calculator and work it out. But you grade 10 who did it just today for the first time, you say, I'm sorted. Wow. I envy you. What happened here now? What happened to my pen? Okay, it's happening. Something's happening. Okay. Okay, let's go back. There we go. Right. Let's do number 2. 1046. 1046 is opposite over adjacent. So opposite over adjacent. So it's a over the square root of 1 minus a squared. It's your final answer. Right. Let's do number 3. Sec 46. Secant. That's 1 over cos 46, which is equal to 1 over cos is adjacent over hypotenuse. So we're done with 1, 2, 3. Khalid, help me out there. The back, there's echoing there. There's certain learners that are just talking non-stop. That's disturbing me here in the front. Thank you. Let's do the next one. Cosec 46. Cosec is 1 over sine 46. 1 over sine is a over 1, which is a. Now it's the last two. Cot 44. Now, which angle is 44? This angle is 44 on the top. Sum of angle. So that's your cot is 1 over tan 44, which is equal to 1 over, now that's, if we're looking at 44, that's your opposite, that's your hypotenuse, that's your adjacent. So we need opposite over adjacent, so that's square root 1 minus a squared over a times a over this times its reciprocal, a over 1 minus a squared. What denominator we do to the numerator. Your final answer is a over the square root of 1 minus a squared. Please master this. This example that we've done, you might see it, you might not see it, you might see it in final. It has come out in a grade 10 past paper before, but definitely 110,000% you're seeing it in grade 11 and 12. For some of you that are going to make it, I wish all of you. I know who won't make it, don't worry. Now I know who won't make it. The supercomputer. You know who's the supercomputer? Don't worry, I know where you are sitting. I'm watching you. The one who from yesterday is not writing. He's just saying everything is processing. Don't worry. You'll be on maths diet next year. Maths light. Maths zero. You'll be doing low-calorie mathematics next year, watching your calorie count. Right. Sine 44 is opposite over hypotenuse. Root 1 minus a squared over 1, which is the square root of 1 minus a squared. And remember, if you're not going to work this year, and if you drop to maths light, or you just drop out, it's not going to affect the world in any, it's going to affect your world. The rest of the world is going to carry on, Baba. The rest of the world is going to go on. They're going to advance. People are going to achieve. If you think it's fun to fail, no, it's not fun to fail. You'll know. If you think living with mathematics is difficult in life, try failing maths. See that. The other side, don't worry. Some of you are going to know very soon. Right. There we go. We're done with that. I'm just spitting facts. Right. Here we go. Last one here. We're now going to give you a diagram. Let's just... All right. Let's have a look at this. Take this diagram down. Let's do that. Let's do that. There we go. From there to there. From here to here. That line is parallel to that line. A, K, D, point D, point C, point B, 55 centimeters. That's 12 degrees. That's 48 degrees. Right. Use the diagram and calculate. They want the length of CD for 6 marks. Calculate the length of CD for 6 marks. That's a D. Okay, let's do this together. Shh. Right, so we need CD. We need that small piece. Right. Would you agree with me if I find CB, then I find the whole of BD, and I say that minus that, it will give me that small piece there. If this big piece here is, say, 50, and that small piece there is 20, 50 minus 20 is how much? So I'm just giving you an example. So, hey, so let's first calculate BC. Let's calculate small piece from there to there in the one triangle. Right. So I need this. This is my unknown and that's my known. So that's my angle. That's opposite. That's hypotenuse. That's adjacent. I need O and A. So from Sokatoa. What is O and A? Sine, cos, or tan? 10. So tan of 48 is equal to 55 over BC over adjacent. Are you all following me? Now I need BC on its own. So you guys cross multiply, am I right? So you say BC tan 48 is equal to 55. So BC equals 55 divided by tan 48. BC equals 55 over tan 48, close brackets, equals 49,5. So this piece is 49,5. Right, now we need this big side here, BD. So in the big triangle here, let's see, can we get it? Anything else given? No, nothing else given. Right. How are we going to get to BD? Because I got a side. Do I have an angle, a whole angle like A or D? No. But can I find A or D? Yes. Either A or D we're going to find. How are we going to find A, the whole of A, or we can use sum of angles of a triangle here. Watch here, in this triangle here, we got this angle to be 12. So what is this angle here? So angle BAC is equal to 180 minus 90 plus 48. Sum of angles of a triangle. BAC. Sum of angles of a triangle. This is equal to 180 minus 90 plus 48 equals 42 degrees. So there we go, 42. Now we got that whole angle. That whole angle is 42 plus 12 is how much? 54. Now I can say 10 of 54. So now I can go back. I want BD. So we got 49,5. So now I'm going to say 10 of 54. 10 of angle 54 is equal to opposite, which is BD, over 55, AB. So I want BD on its own. So times 55 times 55, BD equals 55, 10, 54, 75,7. So this whole thing is 75,7. Now we got the small piece. We got the big piece. Now I want CD. Therefore, CD equals big piece minus small piece. CD equals 26,2. Finish. Problem solved. Guys, we've come to the end of trigonometry for the year. Well done, well done, well done. This one here is this girl. Just call this girl here with the class. I think you left us earlier when you came here. No? Your worksheet, Maniano learner? It wasn't you? I swear it was you. Didn't it come from your book? Somebody left your worksheet here? Okay, fine, I'll take it. Right. We are done with this. Let's go into Euclidean. Let's go into Euclidean. Euclidean geometry. All right. Let's start off with some easy ones that you will be asked on this year as well. Before I do parallelograms, before I do quadrilaterals. Okay. I'm starting off with the easy one. Right. A, B, C, D, E. A, B, C, D, E. That is parallel to that. 40 T, X, 40 degrees, T, X, Y, 55. Right, with reasons, find X, Y, and T. Find X, Y, and T with reasons. Thank you. Let's go. We got, now remember, we have a triangle. Sum of angles of a triangle equal to 180. Angles on a straight line, adjacent, supplementary, add up to 180. And then we got parallel lines. So we got corresponding or alternate or co-interior. Fun. Remember from last year? Right, so let's go. Start with the known. Start with the known. 40. So if that is 40, Y is 40. Alternate angles. x. So now we got 40, put it in here. Angles on a straight line add up to 180. So x plus 40 plus 55 equal to 180. What's the reason? ADJ-SUP. Adjacent supplementary. It means angles on a straight line add up to 180. Guys, so x plus 95 equal 180. X, that's an equation. 180 minus 95, 85. So x is 85. Now t, you can either use sum of angles of a triangle, or you can say there's a direct link between 55 and t. Alternate. T is equal to 55 degrees. Alternate angles equal. Right. Okay, I'm going to pick it up in levels of difficulty. This is basic. This is baby work, light work. Okay, let's do another one. Quiet. Take this one down. Right. This angle here is 5x minus 50. This angle is 2x plus 10. This angle on the top is x. This is triangle PQR, and then that point is S. Right. Find angle Q. Find the value of angle Q for 4 marks. Question, answer. Okay, let's go. What must we do? Solve for x, am I right? And how do we solve for x? It's a triangle. What law do I have? This is the exterior angle of a triangle. So we know that the exterior angle of a triangle is equal to the interior opposite. Yes or no? So we're going to go 5x minus 50 is equal to 2x plus 10 plus x. Now you put the reason. They'll give you a space for a reason. You'll say exterior angle of triangle is equal to the sum of the interior opposite angles. Now let's solve for x and then we solve for q. So 5x minus 50. Can you see how important equations are? This is equations from algebra that's used in Euclidean, that's used in geometry. 2x plus x is 3x plus 10. So 5x minus 3x, 10 plus 50. 2x is equal to 60. X is equal to 30. Therefore, angle Q, the question wants Q. Q equals 2x plus 10. We got x. 2 into 30 plus 10. 60 plus 10. Angle Q equals 70 degrees. Don't forget congruency from last year. Side, 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 side angle, side angle, right angle, hypotenuse, side. Don't forget that. Okay. Let's see how smart are you. Okay. Right, take this one down. They give you a line like that. They give you two parallel lines. They give you that. They give you that. They give you this. They tell you this line is parallel to that line. This is angle. That angle there outside is angle F1. This is X, that is X. That is Y, that is Y. This is D. This is B. Prove that F1 is 270 degrees. Prove that angle F1 equals 270 degrees for 5 marks. Right, I'm just going to look for another one while you're doing this. Right, after this one, we are now going into quadrilaterals and parallelograms. It's 25 to 3. We only got 20. Right, watch her. Now, what do we know? These two lines are parallel. So we know that this angle plus that angle. So 2x plus 2y is equal to 180 degrees co-interior angles. Yes or no? Now divide by 2, divide by 2, divide by 2. What am I left with? X plus y equals 180 divided by 2 is how much? 90. Yes or no? Now wait. Now in triangle BFD, let's look at this triangle. We just proved that x plus y equal 90. So x plus y equal 90. Yes or no? So therefore, how much is the angle? Let's call this angle F2. Therefore, angle F2 equals 180 minus 90, x plus y. Sum of angles of a triangle. So angle F2 equals 180 minus, we got x plus y is how much? So 180 minus 90 is? So that means F2 is 90. Therefore, angle F1 equals 270. Angles around a point, a revolution, a circle. Angles around a point add up to 360 degrees. That's our answer. That's what they wanted. You had to prove that F1 was equal to 270 degrees. Right. We're almost at the end. It's 25 to 3. Let's go into some properties of our quadrilaterals and parallelograms. Then we'll do one or two examples just to show you how it's applied. Then we're done. We're at the end, guys. Okay. Now remember, what is a quadrilateral? It's a four-sided figure. Yes or no? So put there, properties of quadrilaterals. Quadrilaterals. Right. It's a four-sided figure or four-sided shape. And we know that the sum of the angles add up to 360 degrees. Yes or no? Give me examples of quadrilaterals. Give me examples of quadrilaterals. A square, a kite, rhombus. What else? Square. Yeah, trapezium. Rectangle. Right. Thank you. Now, parallelograms. What is another word for parallelogram? Palm. Right. Now remember, all quadrilateral, all parallelograms, all palms are quads. They're four-sided figures. But not all quads are palms. Which of these examples are not parallelograms? Which, all right, a square. Is a square a parallelogram? Yes. Is a rhombus a parallelogram? Yes. Is a square a parallelogram? Yes. Is a rectangle a parallelogram? Yes. Is a kite a parallelogram? No. Is a trapezium, you know, a trapezium looks like that. How can that be a parallelogram? Remember, the opposite sides of a parallelogram must be equal and parallel. So the trapezium is not. Trapezium, only one pair of opposite sides are parallel. Right. A kite, very important. Remember, we did this in analytics today. Right. There's a kite. What are the properties of a kite? The adjacent sides are equal. Yes or no? And the diagonals bisect at 90 degrees. Trapezium, only one pair of opposite sides are equal. Who knows what's the area of a trapezium? Because sometimes in analytics, they might ask you for the area. They might give you a trapezium. You know, in analytics we did this morning. So say they gave you something that looked like this. And they told you to calculate that, and they told you that is parallel to that. Now you know that's a trapezium. What if in analytics they asked you to calculate the area of a trapezium? And say this was 90 degrees. What is the formula for the area of a trapezium? It's very important. It's asked in grade 10. It could be asked in 10, 11, and 12. So it's very good to know this formula. It's half of the sum of the parallel sides times your perpendicular height. The sum, we're talking about the length. So let's say this from here to here is 10 units. Let's say from there to there is 30 units. Let's say from here to here is 20 units. Or let's say 5. Let's say that's 5. So area is equal to half the sum of the parallel sides, 10 plus 30, multiplied by your perpendicular height, which is 5. 10 plus 30 is 40. 40 times 5 is 200. 200 divided by 2 is 100 square units. Or unit square. Very, very good formula to remember. Half the sum of the parallel sides, the length of their sides, times your perpendicular height. Don't forget this. Just going to write it here on the side. Don't forget. Onliners, we're almost done. Okay. Now, we know, listen, in a parallelogram, what do we know in a parallelogram? We know that the opposite sides are equal. We also know that the opposite sides are parallel. We also know that the diagonals bisect each other. And one more big property. The opposite angles are equal. Very good. These are your properties of a parallelogram. Now, when you want to prove a shape to be a palm, you don't need to prove all. You can either prove the opposite sides equal, then that would be a palm, or the opposite sides parallel, or diagonals bisect, or opposite angles equal. But the most common ones are either the opposite sides parallel or you don't need to prove all. If it is a parallelogram, it means all four things. But when you're proving it to be a parallelogram, you only need to prove one of the conditions, not all. Are you listening? Good. Better listen. We only got 10 minutes left. We're at the end. Now watch. Let's have a look at this one. So let's take this one down. Take it down with me. It's an easy diagram. It's not a difficult diagram. From here to there. And from there to there. Okay, pay attention. This is A, EB, DFC, this piece is equal to that piece, E1, F1. They tell you A, B, C, D is a palm. AE equals FC. They give it to you. Prove that EBFD. Prove for 5 marks that EBFD is a palm. Right, let's see. So let's see what's given to us here. A, B, C, D is a palm. That means that is equal to that, is equal, the whole side is equal. We also know that this side here is equal to that side there. We also know that this side here is parallel to that side there. That's A, B, C, D being a palm. AE is equal to FC. There we go. We put it. Prove that EBFD is a parallelogram. Shh. Now this is very easy. Pay attention. Right. We know that this whole side here is equal to the whole side there. Yes or no? Right, now pay attention. Pay attention. So I'm just going to take that out there because that's the whole side there. That, right. So we know that this whole side is equal to that whole side. So this is the way you're going to answer it. You're going to say A, B is parallel to DC. Right. AB is parallel to DC. Why? Because ABCD is a palm. Opposite sides of palm ABCD. So we know now, pay attention, we know that that side there is parallel to that side there. We also know that AB is equal to DC. Opposite sides of palm parallel. Now we also know that the two sides are equal. Opposite sides of palm parallel. Right. So this whole side equals that whole side. We also know that AE equals FC given. Therefore, this, look, that whole side is equal to this whole side. Then that small piece is equal to that small piece. So what can we now deduce? That this piece here is now equal to that piece there. Therefore, EB from here, from EBFD, EB is equal to DF and EB is also parallel to DF. Therefore, EBDF is a palm. Why is it a palm? One pair of opposite sides, one pair of opposite sides are equal and parallel. So in any diagram, in any quadrilateral, if one pair of opposite sides are equal and parallel, it will make the entire diagram a parallelogram. So you don't need to prove that the opposite sides are equal and the opposite sides are parallel. If you can prove that one pair of opposite sides equal and parallel, it will make it a parallelogram. Okay. Right, let's go, let's go, let's go. Let's do the last one. That's the last one we're doing for today, before you go home. Here we go. We're at the end, guys. We're at the end. You guys are flipping amazing. 2 whole days. And guys, I'm coming back again in August for your September, before your September assessment. Then I come back in October here before finals. And finals, we're taking a whole lot of past papers and we are just cracking it, right, to prep you for the final exam. Right, A, B, C, D. They tell you A, B, C, D is a rhombus. Take this down. A, B, C, D is a rhombus. Right. And D, AC equals 10 centimeters. DB equals 8 centimeters. Find the length of AB. That's O. So AC is 10. AC is 10 centimeters. DB is 8 centimeters. Find the length of AB. So now we know this is a rhombus. So we know that is parallel to that. That is parallel to that. All 4 sides of a rhombus are equal. Remember, a rhombus is a tilted square. Only thing the angles are not equal to 90 degrees. Yes or no? But we also know that the diagonals of a rhombus cut at 90 degrees. And the diagonals bisect each other. That means that piece there is equal to that piece there. And we know that this piece here is equal to that piece there. Right. Now, because we know the properties of a rhombus, to find the length of AB, I can work in this triangle here. We know that this is 8. If this is 8, then this is 4 and that is 4. Because the diagonals bisect. If this is 10, then this is 5, and that is 5. Yes or no? And if we work in this triangle, we just use Pythagoras. So we say, but wait, you have to say this. Shh. You have to say AO equal OC and DO equal OB and DO equal OB, diagonals of a rhombus, diagonals bisect each other. Then you can say, therefore, AO equal 5, OB equal 4, and they meet each other at 90 degrees. Therefore, AB squared equals 5 squared plus 4 squared, Pythagoras. AB squared equals 25 plus 16. AB squared equals 41. Therefore, AB equals the square root of 41. Boys and girls, we've come to the end of 2 days. Onliners, I would just like to say thank you so much to all the participating schools. For all of you, you guys are super amazing. Give yourselves a nice round of applause, guys. Beautiful. Good luck for your exams. I hope you enjoyed the 2 days. I hope you learned. We did so much of maths. We did 6 months work in 2 days. I'll see you guys again, God willing. May the good Lord be with you. Enjoy your exams. Make us proud. And I'll see you guys in August. See you guys. Thank you all. Lots of love from us. Good luck and God bless. Bye, guys. Onliners, thank you all for joining. And we'll see you guys again in September.
South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history, and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare, and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.